Hi and welcome. This time around we have a couple of quick projects. Another vacuum fixture plate for that laser welding company. This one's going to be really simple. It's going to have a post down the center with a hole through the middle that mounts in the vacuum fixture and then just decked off the top. And then they want to have some material that'll help make a good vacuum seal. So I got some of this different durometer sorbethane, which is a polyurethane. Here's some thicker stuff. And I'll give them some options to try some. The 70 is much denser and doesn't squish in as much. The 50 is pretty squishy. And that kit that I got that I showed in one of my previous videos helped me pick these out, which is pretty handy. And then I'm going to make a mandrel real quick for these guys. And I'm going to try single point threading in an unusual manner that solves some problems, and we'll see how that works out. One thing of note is that you'll notice this is extruded 6061, and I normally use tooling plate because it's already flat on two sides, but the tooling plate is a different alloy of aluminum that doesn't weld well, so I had to get some extruded stuff. First up, we're going to cut the material to size. It's amazing how quickly this saw goes through 1/2 inch aluminum. This extruded stock is pretty good dimensionally, so I'm going to use this bottom edge, which is part of the extruded side, to clean up the side that I just cut. These two sides, as a matter of fact. So I'm going to put this side bottom flat on my vise, down like that. This doesn't have to be any kind of precise, but I just want to get it to dimension. So we're going to clean this side up, then flip it over and clean that side up, and we'll get it square, and then we'll do these other two sides and get it to final dimension. It's amazing that there's even a little bit of vibration in this guy, considering it's fairly thick material, but even 1/2 inch aluminum is not stiff enough when it's sticking out a few inches to completely prevent vibration. You could hear it. Don't really see it, and the finish is good, so that's all that matters. So we're ready to do the end. So my standard approach for measuring this is take a large set of calipers and you lie them flat on the vise so that you know they're parallel, and then bring the jaws in and make your measurement that way. Except I don't have enough stick out, so that's good. Okay, so we're before we even start, we're at 6.082. All right, next up we have to drill a hole in the center of this plate, the rough center, not the exact center, that doesn't matter. We're going for an annular cutter the size I happen to have. I don't have 7/8, so I'm going for 13/16, which is close enough. And then I'll make the mandrel, or the shaft that's going to fit in this, 13/16 as well, plus whatever I need for being off dimension. Beautiful. All right, first up, we got to drill a hole through the center of this guy. Okay, we got a hole of just an approximate size. There's nothing in particular that we're looking for here. It's just something to suck the vacuum. And we need to turn 2 inches of this to 1 1/8 diameter. a little bit of a chamfer in this guy. And then I can face the end off. And then I need to turn back a section a 1/2 inch long, 0.816 in diameter. And we should be good to go. We need to weld it up and we'll come back. Missed a quick step, forgot to part it. So, cleaned up this side, obviously because I just cut fresh material and didn't use any cutting fluid. I'm going to press this in. It's a little bit of an interference fit, not much. And then we're going to weld along the top and we'll be right back and we're going to face this whole piece off. So I want to clean up the weld back here a little bit, and it's kind of crazy to get to, but I think we can do it, except I don't know that this is going to clear, actually. I should check that first, shouldn't I? Ooh, just. Okay, we're good. We're going to go slow RPM. I'm just going to walk this in. Okay, and now we just need to face off the front, and I can clean the rest after. My welding skills on really thick material with a 280 amp welder, not so great. Had some serious problems, as you can probably see. Well, serious. I couldn't get a pretty weld, that's for sure. So, all right, let's just face the front. So we got a nice beautiful face out of here, all the same thickness, and I think we're done with this part. We'll just have to let the vendor check it out and see if it works for him. Although by no means perfect, I cleaned up the weld a little bit with a Dremel tool. Embarrassing to look at. Front's nice, and hopefully it'll work. Thanks to my sloppy welding skills, I put all kinds of weird divots on the shaft. So I filled them with steel epoxy, and I'm going to turn this down. I popped this in a 4-jaw chuck, and I'm just getting it centered now. And once we get it centered, we're just going to take a skim cut. I actually had this like a couple thousandths over dimension anyways, so I'll be able to actually go into the aluminum and hopefully we'll end up with a nice clean surface. So like I said, we're just going to skim. Take off hopefully a thousandth. Looks much better. Some of the epoxy came out of some of the divots, but hopefully this will grab well enough. We did clean up that weld nicely, so that's good. Yeah, I'm a little disappointed about some of the epoxy. It didn't stick very well. I guess it's not deep enough divots. All right, we'll see if this works for him. If it doesn't, I'll have to remake it for him. It's my bad, of course. My welding skills definitely are lacking. So that's it. Thanks for watching. Hope you find it useful. Hope to see you next time.